that. Hopefully you can still hear me, hopefully you can see me, and hopefully you can see my screen. We're going to talk about modern SQL. Now, I must apologize in advance. The reason I sound like a late night radio DJ and the other reason the microphone is so close to me is I've had a terrible throat infection this week. And so I'm talking quite quietly in order to hopefully get through the entire time without losing my voice. I would imagine you would lose a lot of interest fast if my voice disappeared. To get in touch with me, I love talking about technology, so you can reach out to me on Twitter. That's probably the best for just short, sort of casual communications. If you like your technology in a longer form, you can get to me on my blog, conmcdonald.com. And if you're into video, and let's face it, you're on a webinar, so you have at least some comfort with video, you can check out my YouTube channel. And as I've noted there, my ability with languages is nil, and therefore we'll be continuing this presentation in English. If you do like longer forms of people like me just talking tech, I also have a podcast as well. There'll be episodes coming out regularly there. I started that this year, so hopefully there's something in there for everyone, depending on what your preferred version of technological content is. Now, before we begin, I always say this probably for the last 2 years, I can't urge people enough to follow their local laws, their local guidelines. Let's get ourselves all vaccinated or whatever you have to do in your local jurisdictions. Whilst I've certainly enjoyed doing these virtual events, it's made me able to get to events around the world that I normally wouldn't have. I would love to visit you all in person. And so hopefully we can get our communities back to full strength next year as we start opening up our borders. So please get vaccinated. Let's make our communities back to face if possible. Now, the big question you may be asking is, why talk about SQL? Why talk about something that is so incredibly, I suppose, done to death? It's an old technology. If you throw your mind back all the way back to, say, Microsoft Windows, the very first version, SQL predates that. It came out well before even Windows existed. So you would think that there probably isn't a lot to talk about that hasn't already been spoken about when it comes to SQL. But here's my driving motivation for why we should always be focusing on SQL and SQL techniques. Nowadays, applications are far more complicated. It used to be you would have a program and it connected to the database. Nowadays, in the world of microservices and app servers and et cetera, there are so many layers that applications sit away from the database. But still, the very, very middle part of all applications is always a data store. So if that goes wrong, it very quickly bleeds out to the rest of the other layers of the onion, and people be phoning up saying my application, my web page, my mobile application is running badly. And ultimately, a lot of these things can be tracked back to just bad SQL. But this is not a SQL tuning talk. This is about SQL techniques such that you can get more power out of your SQL toolset. Now, 2 key points I want to make as we get started. This session, number one, this session is not about me being a smartass or me saying, look at these incredibly huge, complicated pieces of SQL just to sort of, prove how clever I am, because that doesn't really help you. You can, of course, do almost anything in SQL. For example, let me give you a quick example here. There's the first page of a piece of SQL. There's the second page. I didn't write this. I'm giving a shout out here to a friend of ours named Anton in the community. What does that piece of SQL do? Well, you may be familiar with the game of Sudoku, where you have to fill in the squares. That SQL, if you pass in the board as a string, I've just sort of taken the board and made it into a string with some ASCII characters, it will solve Sudoku. Now, just in case you don't believe me, let me do a new share. And let's prove that this actually works. So there's the board. There's the first page of the SQL statement you saw before on the slides. There's the second page, and we'll give it a run. And there's the solution. Now, you still might not be convinced. You might be thinking, well, I've just filled in the blanks and done a bit of sort of magic there. So I've taken out the terminating conditions so we can see the SQL going through its paces. We can see it doing all of its work. So if I run it again with that one clause taken out, you can see it actually brute force works its way through all the answers. I should have put an order by in there. Let's run it again. There we go. You can see it slowly fills in all the 81 characters that were missing just with brute force, and eventually gets to all 80 or 81, and then we reformat it nicely at the end to make it look like a Sudoku board. Back to the slides. So we can do anything, obviously, with SQL. Similarly, here's another example, which we're not going to dwell on. This one's obviously a lot more dense, but if you run this, courtesy of a friend named Rob in the Netherlands, yes, you get the Mona Lisa. Now, that's two examples of things that the reality is we don't spend our daily lives doing this. The percentage of us that need to do things like solve Sudoku or paint the Mona Lisa in SQL, I would imagine is very, very low. Obviously, as developers in our applications, we need to get real stuff done. So this whole session is not about, clever tricks with, Sudoku or the Mona Lisa. This one's all about just getting stuff that I think is going to be useful for building successful applications on your databases. Now, the second key point I want to make is a little bit of controversy here when it comes to writing good SQL. It's not just about the SQL. If you want to be a successful author of a SQL language such that your applications run well, you need to be good friends with your DBA as well. Now, that sometimes can be a little bit controversial because in many places there is this huge gap between the DBA and the developers. I find this an absolute tragedy, and it's not just a logical gap. Sometimes it's actually a physical gap as well. The DBAs sit in one building, the developers sit in another, or the DBAs sit in another country and developers sit in the other. So there is this issue with this big gap, and that obviously creates problems. This is what developers think of DBAs sometimes. Say, oh yes, that's the older people, that the dinosaurs that sit in our organizations. They've got strange taste in footwear and they drink sherry and things like that. And conversely, when you ask the DBAs what they think of developers, they go, well, it's those Red Bull drinking, Justin Bieber loving, can't wear their jeans properly sort of group. So often there are various friction points between the DBA and the developer community, but that relationship, having close ties between DBAs and developers, is critical no matter what SQL you're writing. Let me do another demo here for you. Oops, let me get my typing right. Let me show you why that relationship is critical. I've got a table here called My Transactions 1. Let's just assume it's customer transactions. So I've got a customer ID and a transaction ID and a transaction date, etc. There's no rows in it. I'll load it up with 200,000 random rows. This table called tab 200K just has 200,000 rows in it. Let's see what it costs to find the information for a particular customer. Let me show me all the transactions for customer 160. The first time I run it, it took 529 consistent gets. That's the amount of I/O it really had to do. Part of that was actually parsing this SQL, trying to work how to run it. So the second time I run it, it's 378. We know how to run it now, but that's consistent from that point onwards. I keep running it, and it's still 378 no matter what. So we've reached that steady state where the cost of getting customer 160's transactions is 378 IOs. Let's now create My Transactions 2, which looks exactly the same. It's customer ID, trans date. It starts off as empty, just like My Transactions 1. I'm going to copy the data from My Transactions 1 straight into My Transactions 2. The tables are identical. In fact, if I count the rows, you can see they've both got 200,000. If I do a minus, you can see there is nothing in Transactions 1 that's in Transactions 2, and nothing in Transactions 2 that's in Transactions 1. These two tables are identical. If I look at the indexes on there, just in case you think there's something wrong there, they both have a single primary key of customer ID and trans ID. They both are identical. Let's refresh our memory. A query against My Transactions 1 for customer 160 still takes 378 consistent gets. That's fixed now. Let's now do a query against My Transactions 2 for customer 160. It's 97. And don't forget, that's the first time we ran it. If we now run it now that the parsing has been completed, it's now 18. That's 20 times faster, and obviously very, very impressive. We're not going to dwell on why it's 20 times faster, but it just goes to show for the same piece of SQL text, sometimes having a relationship with your DBA to come up with the best data structures for your applications is going to be critical in terms of getting your applications to run well. But the way I thought I'd talk about SQL features is what I'll describe as my typical weekend, the SQL edition of my typical weekend. And I have two boys. This is my first son, his name is Max, and the first thing I need to do each weekend is take him to his basketball games, because that's what you do as parents nowadays. You simply drag your children around to the activities that they need every weekend. When he plays basketball, because it's it's just low level, sort of school level, they don't capture a lot of details about the basketball players. So I wrote myself a little app on apex.oracle.com to capture all the points as they're scored. So what happens is I end up have something looking like this in my table. For each quarter of the game, quarters 1, 2, 3, and 4, at particular times, I have which of the players on my son's name is Max, when they actually scored their points, whether they scored a free throw or 3-pointer, etc. Now, an obvious question that might come out of that is, I need the points per player plus subtotals for each quarter plus the grand total. That's a sort of common kind of output you would expect to see in a report. Show me when everyone scored, but show me at quarter by quarter what the totals were, and obviously the grand total so we know what the total team events were. So I could do it with a few queries. Here's my first query, just getting all the player by player points. Then I can simply sum up by quarter to get the quarter by quarter subtotals, and then I could get a grand total as well. Excuse me. But I really don't want to do that, because that's 3 visits to the database, 3 separate queries just to get one piece of information I wanted, that is the quarter by quarter scores plus the players as well. I can get from 3 to 2 relatively easy using a thing called a roll-up. A roll-up takes the original data as it was before, so that's my first query, and my second query is now a roll-up, which gives me both the quarter by quarter subtotals and the grand total as well. So I've managed to reduce one query. That's still pretty messy though, because now I've got 2 results. I've got the player details at the left, and I've got the quarter subtotals at the right. If I'm building an application to render them as a report or a screen, I now have to do a bit of merging of those 2 data sets. I have to get each individual player's results, and then at the end of the first quarter, put the quarter subtotal in, and then get the next player's results, and so forth. It's finicky for me, it's messy for me as an application builder to actually bring those results together. And people often say, well, I'm just not going to bother with that at all. I'll let the application do all that for me. For example, in, say, something like Apex, I can just show the base data and then ask the application tool, Apex in this case, to do all the aggregations and everything myself. But the problem with those things is applications like this don't know in advance your individual requirements. And so, for example, Apex doesn't do that. Apex simply gets all the data and does the subtotaling manually. It's actually fetching the rows and doing subtotaling in the application tier, which is more CPU expensive and generally slower to do. And Apex is probably not going to do it better than most other applications out there, which aren't Oracle-based. Can we get from 2 queries down to just 1? Well, we can. We can take advantage of the row num combined with a roll-up, because row num is a unique value assigned to every row exiting the query. So now, using group by roll-up with quarter and row num, I get the individual players, then I get the quarter subtotals, and I get the grand total as well, all with one query. This is a very common and cool technique when you need to do various levels of subtotaling, but still retain the low-level data as well. All the totals you could ever think of are possible with manipulations of group by. For example, if I do group by cube on quarter and player, I get quarter and player subtotals, I get player subtotals, I get quarter subtotals, and I get the grand total as well. Cube gives you all the permutations of subtotals for the columns you present in there. But if that's too many, it's totally customizable as well. I can use group by what we call grouping sets, where I'm explicitly nominating the particular totals I'd like. I want totals by player, then I want totals by quarter, and if I just have empty brackets, then that's the sign for a grand total as well. So as you can see, group by is so much more than just group by. Once you get into group by rollup, group by cube, group by grouping sets, you now have a lot of aggregation power, all with a single SQL, which means a single trip to the database as well. It's generally going to be far more efficient. If you've ever used some of the newer versions of Apex where we have these things called faceted search, which is a really cool facility in Apex, because if you had to do this yourself in code, it would be very difficult. In Apex, you simply say, yes, I want a faceted search on the job and salary and department number columns. How do we achieve this without it being too expensive to find all those results? If we throw a trace on an Apex application, this is what we see. We're using grouping sets to find out all the information for the particular facets. So our own code itself, our own products, Apex, for example, we use our SQL extensions to grouping to take advantage of all that power in aggregation flexibility. Once you start capturing information about my son's basketball, then all the other parents start hassling me. They start emailing me with things like this. I saw the report you gave to the coach from the game. It would be cool if we could get that detail broken down for. Now, when they say each player, what they really mean is they would like their son's details. But they always phrase it in a nice politically correct way and say, oh yes, I'm just interested for the benefit of the team. But really they want it for their own player. So let's now explore ways of getting more of a drill down data at a player level. So to get the list of all the quarters, there's no table that has the number of quarters in the game. So we can create one here using the connect by level trick from Duel. That gives us the quarters 1, 2, 3, and 4. And here we have all the details of every single player by quarter as well. So the number of points they scored per quarter per player. And you can see that Campbell scored 10 points in quarter 1, Max, my son, scored 6 points in quarter 2, etc. If I want the player results by quarter, I can just do a conventional outer join from that. For those two sources you just saw, I just simply do a outer join. I've used the ANSI syntax here, but you could use Oracle syntax as well. Now that looks like we've actually solved the request here. Give me the player scores by quarter. But if we look a bit more carefully, my son Max and another person named Matt in the team, they didn't play or they didn't score in a particular quarter. Matt scored in quarters 1, 2, and 4. My son Max scored in quarters 1, 3, and 4. We don't get all 4 rows out because the outer join doesn't work in that way. A conventional outer join simply gives a one-to-one mapping. The issue there is the data is sparse, but really what I want is quarters 1, 2, 3, and 4 for every single player. So this query here, right, isn't sufficient to do that. Ideally, what I want is a copy of the quarter table, those 4 rows, replicated into that join once for every single player in the team. If I was writing that with a conventional outer join, I would have literally that quarter table replicated once for every player. The challenge there, of course, is I don't know how many players are in the team on a given day because that data is stored in a table itself. I have to dynamically come up with the number of times I need to replicate that join. That's complicated. However, we have a thing called partitioned outer join that solves that complexity. And literally it's just a one-line addition to the query. It's the same right outer join, but I simply have a partition by p.player in there. What that's now doing is taking the quarter table, the quarters 1, 2, 3, and 4, and replicating that into a join partition for each player in the table. So now I get the 4 rows for Campbell as before, but now I get 4 rows for Matt, even though he didn't play in quarter 3. You can see I've done an NVL to get the points of 0. And similarly, my son Max, who scored in 6 points in quarter 1, didn't play quarter 2, played 3 and 4, etc. So partitioned outer joins are a great way of inflating data that is sparse. And also it tells me one important thing, my son should be getting more court time. He shouldn't be off in those quarters. Once you have data that's been padded out using things like partitioned outer join, that makes reporting really, really easily. Because, for example, if I'm using Apex here as an example, when I want to do for example, a breakpoint by, say, player, I don't get those sort of counterintuitive effects where I don't get 4 rows for every single player. Often people will, your users will log bugs saying, how come I don't see the results for quarter number 3 for a particular player? Once you can inflate the data with a query, it makes rendering it on application reports or screens much, much simpler. Then a new email comes in. This one's come in from our coach, Mary the coach. She says, hi Connor, we have a new boy who's looking at joining the team. I don't know much about him, but he averages about 13 points per game. Where would that place him amongst the team? Now, if I was doing this and it's just a one-off request, I could obviously just sum up the number of points per game that each player gets and just sort of eyeball down the list. Will gets more than 13, Campbell gets 23, which is more than 13, Robbie gets a bit less, etc., etc. But obviously, I would like a SQL way of being able to do that because that's going to be much more scalable. We have a thing in the database called hypothetical analytics. You don't just have to do analytics on existing data, you can do hypothetical analytics as well. This is what the SQL looks like. Remember the email said this new player gets about 13 points per game. So that first line of the SQL there says, show me where 13 points per game would rank amongst the group of players. And in this case, it says, if he averages 13 points per game, he would be our third highest scorer. Similarly, what if we want to do some analysis at a lower level? This, rather than just being he gets 13 points per game, someone said, well, what if he gets about 4 points per quarter on average, which might end up to an average of 13 points per game if he ends in just less than, if he's getting like 3.8, 3.7, etc. per game. That's a bit more challenging rather than just eyeballing the average list of players now because it's on a quarter-by-quarter basis. But the rank facility, because it has the within group option in there, can also handle group bys as well. So it's the same query. I've got select rank 4. How does 4 points per quarter rank within the group? But now, just because I have a group by quarter on line 9, I'm now doing that hypothetical ranking at the quarter level, not the entire player level. So it's very, very flexible as well. So he would rank 5th on quarter 1 if he's averaging 4 points per quarter. He'd rank 4th in quarter 2, 4th in quarter 3, and 3rd in quarter 4. So normally that's basically my Saturdays taken care of, and I bring my son home, and of course the moment I get home, my second son's going, Dad, it's time to take me to football. Now, when I say the term football, this is Australian rules football, which is different to football or soccer, depending on which country you come from. You can think of Australian rules football as a violent game of keepy-off. My son will be furious that I said that, but yeah, so I take him to his next sport, which is football. These are the kind of questions that come in from their coach. Find the total goals scored for each player, then with the average of those totals, list those players who got above that average. So the kind of requirements that come in from the football coach, who's much more into his statistics, get a little bit more complicated. And of course, I've now got to turn that into a SQL statement, which is challenging. It's a big list of requirements in a fairly lengthy piece of text. One of the great things I love about SQL is common table expressions, or otherwise known as the with clause, when it comes to tackling big requirements. And the reason for that is, before I say the reason for that is, the benefit of using the with clause is it lets you provide nice namings to portions of your SQL. So here I have a SQL which is show me the sum of goals for each quarter, and I can give it a nice name. I can say, from now on, I'm going to refer to that thing as subtotals. So subtotals is that query, therefore select star from subtotals. It's like creating a view on the fly inside the database. At which point I'm thinking, well, what's the benefit of that? Why would I write more code for simply the same result? And I view this as a great mental model for developers. Because let's face it, if we're writing queries against relational databases, the relational database is a rigorous model. It's based in mathematics and algebra. It's also the dominant model. The vast majority of applications are still written on relational databases. NoSQL sort of had its moment, but it seems to be sort of dropping in terms of popularity as people realize how hard it is to deal with them. But relational can be complicated when it comes to very big requirements, and you have to turn them into a single SQL. Now, don't get me wrong, that's not our fault. I don't blame us as developers for that. I blame this guy. This is Dr. Codd, who's the first person to write down what relational theory was. Data is represented as mathematical n-ary relations, and n-ary relation being the sub. When I first saw that, I had no idea what that meant. And most of us don't. We've never put in that effort. For me, I always thought of databases as Excel, but bigger. But the beauty of the with clause is the kind of things that we do naturally as developers, approaching problems in a procedural fashion, we can now apply to the complexity of relational set theory. I can do things step by step rather than having to tackle a large problem in one big hit. So here's our requirement broken down step by step. It said first, find the total goals scored by each player. I can write an SQL just for that. It's select the player, sum the goals, group by player, and I'll call that player total. The second part of the requirement was find the average of those totals. Well, I've got a thing called player total now. I can just do an average, select average from that. I'll call that average goals. And then the final thing was list those players who got above that average. Well, I've got a player total table, I've got an average goals table. It's just a simple comparison of two of the columns. Bringing it all together, I've now got a single SQL which satisfies that quite complicated requirement, but I never had to treat it as an entire unit of work. I could break it into small individual tasks, just like we do when we're writing code as developers. We took a programmer's approach, you can think of it as a bottom-up design, small chunks of work, but we still end up with a nice relational solution. The database optimizer decides how to best run that query. This is also great for code reuse. Modern apps nowadays often are dealing with their data interchange in terms of JSON. XML had its day, now everything's about JSON. So let's go back to our partition joined example just briefly for a second. This was the solution I came up with our partition join. That obviously came back as rows and columns, but if I'm now modernizing this application, I might need to send it to a microservice or something else as a piece of JSON. Rather than have to rewrite the entire code, I can simply say, well, that's my raw data. I'll use a with clause to call that my raw data, and then I'll simply extend this SQL to convert it to JSON. I run that and I get a JSON result as opposed to rows and columns. So the with clause is great at doing code reuse, building upon existing code solutions or SQL solutions to adapt them or modify them for changing requirements. So the basketball is done, the Australian rules football is done, and of course, because they're teenage boys, they now need feeding. And rest assured, I spend most of my life at the supermarket because of the volume of food they eat. The challenge there is when you're buying that much stuff, I need to work out how to get it into the bags. And in this case, you can see I've got 4 bags there. I want to get all this shopping into my 4 bags when I get to the supermarket. And ideally, I probably want to have the shopping divided evenly amongst all the 4 bags, because I don't want one bag full of something, bottles and that, which makes it very, very heavy, and the other one not. I'm getting pretty old. The last thing my bag needs is, a shopping bag that's over heavy compared to the other ones. So here's all the things I've bought from the shopping. I've got my milk, my bread, my dog food, etc., and there's the weight in grams. What I want to do is now evenly distribute that shopping across all 4 bags such that each one has roughly the same amount of weight in it. SQL can even do those kind of things as well. Shout out here to Stu Ashton, who first put this together on his blog. I'm going to define a pattern which describes what I'm trying to achieve. I've got 4 bags here, bags 1, 2, 3, and 4. And what I'm trying to do now is I'm going to come up with some rules such that all those bags will end up with the same amount of capacity or things in them. So which bag should I use when I have a piece of shopping? Well, if the bag is empty, I should probably put something in there straight away. So the first 4 bags will get 4 individual items. But then once I've got something in each of the bags, I now have to start deciding on which bag to use next. So what I'm going to do is I'm going to use this bag if it's the first item in the bag. Otherwise, if this bag currently is the lightest before I put this item into it, this current item into it, then that's the bag. So I'm sort of working my way through to make sure that I'm trying to keep the lightest bag gets the next item in it. And I repeat that rule for bag 2 and bag 3. And I put it all together in what we call a match recognize query. This came out in Oracle 12. And obviously there's a fair bit to this query. There's a little bit longer than your average query. But the basics are still effectively things we want to get back, what measures we want to get back, a pattern, and then a definition of the rules that will match that pattern. This is the output that comes out. Now, it's not immediately obvious where the answer is here, but if we scroll right to the very last row, we can see here's our 4 bags, 1, 2, 3, and 4, and they've got each about 3.5 kilos in there. So I can see this final row here is telling me that, yes, all 4 bags are roughly the same weight. How do I turn this into something that's going to be useful for me? I can use a with clause to encapsulate that first query you just saw. So I'm using the with clause here we just learned about. I'm using this match recognize query we just learned about. And I'll use another facility called list aggregate to actually aggregate the items based on the bag number. I run that, and this is the result I get. Bag 1, I should put the butter, deodorant, the eggs, and bottle of gin for me. That'll be 3.5 kilograms. Bag 2, apples, honey, ketchup, soda, and steak. That'll be 3.6 kilograms, and so forth. So even those complicated requirements of, for example, in this case, making sure the bag weights are the same, I can do it with SQL as well. At which point you might be thinking, well, you said you weren't going to be a smartass with the code. You said all this code was going to be easy, and that looked like a huge chunk of code that we had to digest. And that's, I happily concede that. And someone says, how do I take that query if I've only got 3 bags? Or I don't take bags to the shopping. I take bags when I go to the hardware store. Obviously, if those queries get very complicated, then even what you think are simple requirements, just changing where the data comes from, the number of bags you had, makes those queries quite difficult to maintain. And that leads into our next piece of SQL technology, which is SQL macros. SQL macros are effectively SQL that can write or change SQL on the fly. Now, there's obviously a lot to this particular function. We're not going to go through it in any great length and detail. But what, in a nutshell, it's doing, it's writing dynamically the SQL statement you saw previously. Let me flick back to it. This one. It's dynamically writing this one. Flick forward again. Based on the table name that comes in and the number of bags you had. So it's very carefully putting together that SQL. You can sort of see the template for that SQL being built up here. And then we're going to actually insert a few little bits and pieces to pad out our SQL. Once you've got that, now I can query that function as if it was a table. So I simply do select star from pack and carry. I'm getting my data from the shopping table with 4 bags. This is the result you saw when we wrote the query initially. But now, because the complexity is hidden away, I can say, oh, I also want to run it for 3 bags. And it says, yep, for 3 bags, each one's going to be about 4.8 kilos. And the first bag's carrots, deodorant, detergent, gin, honey, Vegemite. You can see the distribution has changed because I only had 3 bags. But similarly, I can also say, well, I've got 5 bags, but I'm doing my shopping at the hardware store. So at the hardware store, the first bag just had the chainsaw, second bag had a power washer, some pretty heavy items there, and then we had some smaller things which we put into the other bags. So SQL macros are a great way of encapsulating code logic and complexity, and therefore making the reuse much, much more easy. If you are interested in SQL macros, I've just touched the surface here. Chris Saxon is doing a talk on SQL macros, I think today, later on today. So make sure you check out that session, because that'll be a full 45-minute session just on this particular topic of SQL macros. So I've taken the boys to basketball, I've taken them to football, I've fed them. Finally, I get a little bit of me time, a bit of time for me. And for me, if I'm going to relax after all the weekend activities, I'll normally swim laps in a pool. Now, I'm by no means a great swimmer, so for me, for a 50-meter pool, I'm trying to average about 60 seconds per lap. That's hardly Olympic level, that's about half Olympic level, but I'm just trying to do maybe a few kilometers, just 60 seconds per lap, trying to keep it nice and consistent. And what I do is I plot each lap time, because I'm not trying to do one lap in 50 seconds and one in 70. I'm trying to keep it close to 60 seconds the entire time. I'm trying to keep it nice and consistent. So when I look at my elapsed times per lap, I can see that lap 1 was 58.7, lap 2 was 59.7. The average down the bottom there was 59.93. I was pretty close to my 60 seconds, so I'm happy with that. But obviously, the average at the bottom doesn't tell me the amount of variability. In fact, what I'm looking for is effectively like sort of moving averages. So how often am I on track, and how much variability do I have is the question I'm trying to answer. Now I can just eyeball a little bit. For example, laps 1, 2, 3, and 4, if I average them, it averaged 60 seconds, bang on the dot. Similarly, 9 through 12, a couple couple were under, a couple were over, but I averaged 60 as well. If I was really interested, I could also get the variance and stuff like that in there, but we just work on averages. What I'm looking for is continuous sets where I averaged 60. Once again, doing some pattern matching lets me do that same solution, once again, just with SQL. I'm allowed to have off target here is effectively just always true. 0 is when the sum of the deltas, these deltas here, adds up to 0. Then I know that I've averaged 60 seconds for a particular contiguous sets of laps. So whenever I hit a 0, then I've basically got that pattern. So it says, you can see here, laps 1, 2, 3, and 4 eventually bottomed out at 0, which means I was averaging 60. Laps 9, 11, 10, 11, and 12 were off target, and then eventually hit to 0, which means they were averaging 60 as well. So I got the same result there that I did by eyeballing the results earlier. There's the first one, there's the second one. But it's a good thing I use SQL to solve this, because just my eyeballing, where I saw laps 1 through 4 and 9 through 12, I missed one. If I actually look at the eyeballing again, 2 through 10 also averaged 60. And I can even get that with SQL as well, simply by modifying my query slightly to doing aftermatch skip the next row. I get all the various permutations where I could have averaged 60. So 1 through 4 we saw before averaged 60 seconds. 2 through 10 averaged 60 seconds as well. But so did 4 through 10. So did 9 through 12. So the power of pattern matching picked up information that I couldn't see when I was just eyeballing the data. The weekend is over. I've been driving around all weekend. Now I have to fill up the car. And this is our last SQL topic. Now, one of the things I don't refuel every SQL weekend if I can, because there are certain days where the fuel is very, very cheap in Australia. They have this thing called the petrol cycle. And what you try to do is you try to fill up your car when it's very, very cheap, because otherwise during the week or during other times of the week, it's very, very expensive. So rather than filling up my car from when it was empty, so percent full being 0, I put in a whole 45 litres. What might happen is the car might be only 20% full, or it's still got plenty of petrol in it, but I'll fill it up anyway because it was a cheap day. Even if it was 60% full, I might choose a particular day, in this case 13th of August, to fill it up. So that's all well and good. That's making sure I have cheap fuel. But then when I check the owner's manual, they were actually saying that's not such a great thing. They said it's better to actually use up most of the fuel in the tank, because otherwise you get dirt and impurities in the fuel. They even went so far as to give you a little spreadsheet which shows you how to calculate the amount of dirt that you're slowly accumulating in your fuel tank. And what they did was they said, if you fill up from 0, from the tank being empty, then it's just 5% of the number of litres you put in. We can assume it had contained some sort of impurities. However, if the car is not empty, then what you need to do is take into account the previous amount of dirt that's in there, and then effectively, add in what you've a multiplier for the number of litres you're about to put in. Now, that's a bit of a problem, because this isn't even a column in the table. This is a calculation I'm doing. So I don't know how to calculate this value until I get this one, and so forth. So now, the dirt calculation for when percent full of 0 is fine, but to work out this calculation for when I refilled it at 20% full, I need to know what this dirt calculation was. I need a recursive relationship. I don't know how to evaluate this until I've evaluated this one. Now, recursion in SQL seems a very non-intuitive thing to do, because it's not like a program that you call itself, but you can do recursion in SQL as well. The first thing I'm doing is providing a nice simple ordering to my rows, because I fill up on various dates, that's not a nice contiguous set. So I've got a sequence number here using a row number analytic to give me a nice simple sequence. Then I'm going to use the with clause, but a slightly different version of a with clause this time. So the first thing is getting a table called T, which includes my sequence number. Now, to get my results, this table in my with clause takes arguments. In fact, they're columns. And we build this SQL up in 2 ways. The first thing is I need a starting condition, just like a normal recursive program, a starting or a terminating condition. So I'm going to go get the first calculation for dirt for the very first row. If I was doing this more accurately, I would actually ensure that the percent full was 0, but let's assume that if it's the very first time I filled the tank up, it's always going to be percent full 0. Now, to calculate the dirt for the next value, well, I need to know what the dirt was for the previous value. And if we look, this join here is on the results table, but this is the results table. This is a query that references itself. And how do I link one row to the next? I've got a join condition here saying this row results.sequence matches the previous one minus 1. Therefore, I hop back to the previous day. I can actually write recursive SQL in with the with clause, and I get the same result. There's my dirt calculations without having to use an Excel spreadsheet. How are we going for time? We'll get a little bit of time left. Having said, yes, we can do away with the Excel spreadsheet. People often come to me, especially if they're data analysts, and they say, but I like Excel formulas. I can see Excel formulas. Yes, I want to run it against a database because Excel obviously has a lot of limitations, doesn't have a lot of firepower when it comes to doing SQL style calculations, but I'd like to be able to write my SQL as if it was like Excel. And you can actually do that as well in Oracle. Here's my Excel spreadsheet. Can I write a SQL statement that is similar to that Excel spreadsheet? I can, using what's called the model clause. It's not an exact mapping, but it's reasonably close. The first thing I define in my model clause is what we call a dimension. Dimension is effectively defining the left-hand side of your Excel spreadsheet. What's the unique thing that identifies each row? In Excel, it's the little the little column down the left here, 1, 2, 3, 4, 5, 6. We've done that as well. Then, of course, an Excel spreadsheet has columns. They define what we call measures. So I've got date, percent full liters, dirt, and I've got date, percent full liters, dirt as well. Then the rules are the expressions that we have inside an Excel spreadsheet. I've got similar rules here. They look a little bit different, but we can see it's effectively that sort of familiar square bracket representation that we have in Excel, we can actually do in terms of SQL as well. And we get the same result as before. So even if you have Excel expertise, you could look at using the model clause to actually come up with doing similar things in SQL. So let's wrap up. So we finish at quarter to the hour. I've spoken about this 45 minutes being a thing about modern SQL. I actually just call it intelligent SQL. And let me explain why it actually is not what I would call modern SQL. Let's very quickly flip through what we've spoken about today. Grouping sets, row number analytics, hyperlogical analytics, when did they come in? 23 years ago, believe it or not, in 8i release 2. Partition data join with clause, 9i, 20 years ago. The model clause, 10g, 18 years ago. Recursive width, 11g release 2, 12 years ago. Match recognize, 12c, 7 years ago. In fact, the only one you could even probably argue is brand new is SQL macros, which came out a year ago in 19c. So all of these facilities, some of which you may have never seen before, some you have, I'm sure, are all actually robust, old-style SQL solutions. They just don't get used because so many people haven't put in that effort and time to learn the power of SQL. Hopefully this 45 minutes has convinced you that SQL actually is incredibly robust, incredibly cool, and in particular, very powerful for getting the results you want from your data. And in particular, the more power you pack into your SQL, the less application code you'll need to write, which generally ends up being faster, easy to maintain, and more scalable applications as well. Now, if you're thinking, oh, there's a lot of SQL here I need to catch up on, don't panic. It's never too early to start. This is my son, Max. Yeah, we got him onto SQL very, very early. Yeah, he was 1.5 years old there, I think. Now, if you're looking for resources in which to supercharge your SQL skill set, head over to livelabs.oracle.com. There's labs over there. There's a complete databases and SQL for beginners course at bit.ly database for dev. LiveSQL.oracle.com is your 100% free scratchpad. And if you're interested in free stuff, head over to developer.oracle.com/free, where there's just a huge amount of free stuff. Free databases, free software, free training, free etc. We've really worked hard the last couple of years to provide an enormous amount of free resources for you to power up your SQL game. Thank you very much, everyone, for your time. Let me stop the share. Hopefully you've enjoyed that session. Please, if you have any questions, you can reach out to me on Twitter, or just my DMs are always open. Obviously, you can put things in the chat, but obviously we don't want to impinge upon the next person's coming on time. But yeah, thank you very much for having me. I'll be back here again on Thursday. But yeah, hopefully you're having a good session and good rest of the day. I'm going to go rest my voice before it gives out, and hopefully it'll work again on Thursday. So let me hand back to the host and the team. So thanks very much for your time.